It is the topic of class 9 physics book. In this topic, we will show that the work done in moving the body vertically up in the Earth's gravitational field will appear as the gravitational potential energy of the body. Here we will consider three cases. In the case number 1, we consider that the body is lying on the surface of the earth, which is represented by O. In this case, Pe naught is the potential energy of the body, which is equal to the mgh. As we know that the height of the body with respect to the ground is 0, therefore we will put the value of h as 0, and the potential energy of the body for the body which is lying on the surface of the earth will become 0. In the second case, we consider that the body is being lifted up by applying the force F from O to A. In this case, the uh, force which is being applied on the body F and the displacement which is being covered by the body H1, both will be in the same direction. When the force and the displacement both are in the same direction, then the angle between these two vectors will be equal to 0, and we apply the formula of work, which is the dot product and the force and the displacement. In this case, our displacement is h1. Here we will put cos 0, and our work done in moving the body from O to A will become F into h1. It is clear from the figure that the potential energy at point A will be equal to the mg h1. Therefore, our work done in moving the body from O to A will be equal to F into h1. But we must know that the force which we have to apply in lifting the body upward will be equal to the weight of the body. Therefore, weight is equal to mgh. But one an important thing you must consider, yeah, or we must keep into your minds, that the and during this process the velocity of the body is kept constant, because the work uh, which is being done on the body must convert into the potential energy of the body, not into the kinetic energy of the body. But if the velocity is increasing, it means our work, which is converting into the potential energy of the body as well as into the kinetic energy of the body. Therefore, the velocity of the body is kept constant. It means that our work will not increase the kinetic energy of the body, but only the potential energy of the body. So, the potential energy of the body at A with respect to O, it becomes mgh1. Another thing we must consider here, that this work in moving the body from O to A will also be equal to the potential energy of the body uh, at upper point minus potential energy of the body at lower point. In this case, our lower point is the actually the ground or the surface of the earth. Therefore, our formula now mgh minus, we have already calculated that the potential energy at the ground is equal to mg0. Therefore, our potential energy at A will be equal to mgh1, and or we can also by direct applying the formula, it can be shown that it will be equal to mgh1. Now we consider another point B. The perpendicular distance between point A and point B is h, and the perpendicular distance between point B and O is h2. So, the potential energy of point B with respect to the ground becomes mgh2. Now, we will show that the work done in moving the body from O to B will be stored in the body as the potential energy of the body with respect to O. So, we calculate the work done in moving the body from O to A is equal to F into h2. Again, is this force F must be equal to the weight of the body. Weight is equal to mg, and in the last we get mgh2. Secondly, we will show that the work done in moving the body from A to B. Again, the same force F is applied, but now the displacement or the distance which is covered by the body will be equal to h, and this displacement again will be in the vertical upward direction. This h actually is equal to h2 minus h1. Our force will be equal to the weight of the body, and in the last we get weight into h2 minus h1. When we open the bracket, we will get mgh2 minus mgh1. Mgh2 is actually the potential energy of the body at point B, and mgh1 is the potential energy of the body at point A. Again, we will get the same formula that the work done in moving the body from A to B will be equal to the potential energy at the upper point minus potential energy at the lower point. Or we can simply show that we can simply say that this work done in moving the body from A to B will be equal to the difference of potential energy, or the potential energy at point B with respect to the point A. Therefore, we can say that in all these cases, when we calculate the potential energy at any point, for example A or for example B, it will be the potential energy of the body with respect to the ground, and we consider that the potential energy of a body at the ground is equal to 0. Therefore, when we calculate the potential energy of any body, it will be relative to the ground, but as we will taking the potential energy of the body at ground is equal to 0. Therefore, our formula will become simply equal to, for example, Pe is equal to mg h1, or we can say more precisely potential energy at point A is equal to mg h1 minus 0, which minus 0 means the potential energy at of the body at ground. Therefore, this formula, the potential energy of the body with respect to the ground or at point B will be equal to the mgh2, but more correctly it should be mgh2 minus 0. Therefore, in the next video we will consider the absolute potential energy of the body, not relative to the ground, because if our ground surface becomes up or downward, in this case the potential energy for the two persons will be different.